Alrighty, so we'll be doing example 5 and 6 at the same time here to show the differences. You see how these are the exact same numbers, but one is using the regular log log and the other one's using the natural log log, okay? We're rounding both of these to the nearest 4 decimal places. All you have to do is plug them into your calculator with the regular log button. So we do 6, 4, 5, 7, 7, 8, and we get, let's see. Sorry, let me do my marker. And we get 5.81000832. So when we're rounding to the nearest 4, we box off everything that does not count to the 4. So there's 1, 2, 3, 4. This number right here is greater than, it's 5 or greater, so then that means this becomes a 1. Okay, so for the final answer, we have 5.8101. Okay, so now let's do the same thing, but instead of LN, we're going to use, I don't know why I did that. We're going to use LN. So we have 6, 4, 5, 8, 7, 7, 8. Okay, so the point of showing you this is that log and natural log are not going to give you the same thing. Remember log 10, there's an imaginary, log, there's an imaginary 10 here. In ln, there's an imaginary e here, right? That's bad notation. It should be loge, but I'm going to write it poorly just so I can explain it to you guys, okay? So essentially, remember when you're solving these, it's this little base raised to what gives you this big number, right? When we're doing the cycle, example 1. So obviously you're going to get a different number if your little number is a different one, okay? So here we have 13 point, make sure you guys are practicing these in your calculator, please. 1107, okay? So we're rounding to the nearest 4, so we do 1, 2, 3, 4, so that's everything here. This number right here is smaller than 5, so we actually keep everything the same and just get rid of it. Alright, now we do our next one, which is log 0.000239, and we get negative 4.621602. 1, 2, 3, 4. The next number was a 0, so we can just get rid of it, okay? If we do ln of that exact same number, we get negative 10.64163321, okay? If we box off the things that don't matter, this is smaller than 5, so we just get rid of it, okay? Over here now, if we were to do log of negative 3, don't hit the minus sign, make sure you use the negative button, we get error, okay? So this right here does not exist, okay? And if you recall, remember when we're looking at the graphs, we know that e to the x looks like the start of a cursive e, right? This is e to the x and it goes to the point 0, 1. And we know that logarithms are the inverse of e to the x, so it flips over this y equals x, right? So this is what your logs look like, right? ln or lng, and it goes through 1, 0. Now, we have a horizontal asymptote for your e, because it never gets to this y equals 0 line. But we have a vertical asymptote for our logs, because as it's going down to negative infinity, it's never going to touch our y-axis, okay? So to say that this x can be negative just isn't true. Does that make sense? So your domain, or your x's for your e, can be anything, but your domain for your logarithms has to be greater than 0. Cool. So same thing over here. Again, you'll get does not exist, okay? And you can always practice that in your calculator. See if it works. Make sure you use the minus and not the negative, okay? We have ln e. Remember, ln has an imaginary e. So we have e and e. Whenever you see the same thing, it always cancels out and gives you a 1, okay? That was a little thing that we learned last time, right? So whenever you have the same 2, it's always going to cancel out to a 1. Whenever you have a 1, that's always going to give you a 0. But if you want, you could practice that in your calculator. sometimes when you do the calculator, you have to look for your E. Our E is here. We have to hit yellow. So I do yellow, and you see how it gives you a power. If your calculator makes you do a power and you don't need a power, you just put a 1, right? And we get 1, okay? And then we can do ln of 1, and we get 0.